Okay, we will continue the differentiation of the trigonometric function and inverse function of trigonometric. Okay, let us see if y is equal to tan x. We know that in this situation at negative pi, what is actually the domain of this function to be continuous is from pi over 2 to negative pi over 2. There is no equality sign also, because at pi over 2 there is a discontinuity. Therefore, if you take it in this interval, the function will be actually continuous. And the range of this function is r, all the real number. Therefore, you can say the range is equal to r. And then the domain is between negative pi over 2 to pi over 2. Now, if you are going to define y equal to arc tan of y, arc tan of x, so in that case, the domain of the function will be r, and the range of the function will be open interval minus pi over 2 to pi over 2. Now, if you want to differentiate this one, we can say that x is equal to tan y. Therefore, derivative of this function is 1. If I differentiate with respect to differentiate x with respect to y, I'm getting dx by dy is equal to derivative of tan y with respect to y. Differentiate x with respect to y, I am going to get 1 plus tan square of y. You may remember it is the derivative of tan is 1 over cos square of y, or 1 plus tan square of y. All these two are exactly same. These two are exactly same thing. So I write it in this format because I need to substitute for tan y. You know that tan y is equal to x, therefore dx by dy is equal to 1 plus x squared, because tan y here is equal to x. So this will be 1 plus x squared. Therefore dy by dx is equal to 1 over 1 plus x squared. I am making these mistakes very often because I got used to write tan y over tan x, then this dy should be in the denominator there. Okay, therefore this is the derivative of the function tan arc tan. Now suppose, give an example, find dy by dx for the function y equal to arc tan of x squared. Now dy by dx, again you can see that it is u here, therefore we are having 1 divided by 1 plus u squared. U squared will be x squared times du by dx, which is 2x. Therefore, the final answer will be 2x divided by 1 plus x to the power of 4. So this is the derivative of arc tan of x. Now, for example, you can give another one. Find the equation of tangent line to the curve y equal to x times arc tan of x at x equal to 1. Now, okay, first of all, if x is equal to 1, I need to find a point, therefore I need to find y. Therefore this will be 1 arc tan of 1. Make sure your calculator is in radian mode. Therefore, this gives us y is equal to pi over 4. Therefore, the point is 1 and pi over 4. Now, I need to find the gradient of the tangent line. Therefore, I need to find dy by dx. You can see that y is a product of two functions. Therefore, the derivative of x will be 1 times, the second one will be arc tan x plus, now derivative of the second one times x. Therefore, x is this x here, so that now I need to differentiate arc tan. Arc tan is 1 divided 1 plus x squared. Then at x equal to 1, what I'm going to get? I'm going to get dy by dx is equal to arc tan 1 plus 1 times 1 divided by 1 plus 1 squared, which is arc tan of 1 is pi over 4, so this is pi over 4 plus 1 over 2. That is our n. Then now different people are using different way of writing what do you call it, tangent line. Most of you are using y equal to mx plus c, y equal to mx plus c. Now m we know that is this, y is actually pi over 4, then this is pi over 4, this is equal to m is this one, pi over 4 plus half, x is 1, therefore times 1 plus c. Now you can see that from here this pi over 4 cancels this pi over 4, c will be negative half, therefore c is equal to negative 1 over 2. Now then I can write the equation, therefore y will be equal to m was pi over 4 plus 1 over 2 times x minus 1 over 2. So this is the equation of the tangent line to the curve. Now, another thing you are supposed to discuss if it is implicit differentiation. Now, if you are having your function is implicit format, what I mean by that? That means your function is in the form of f of xy equal to c. That means x and y are mixed together, and maybe it is not even a function, maybe it is a mapping, a relation. So that means for one value of x, you may get two values of y. But anyhow, we can differentiate this. Or we can restrict, as we have done it before, for the arc, sine and cosine, we can restrict the domain to make it a function. For example, a circle is not a function. But anyhow, you can differentiate that equation. Now, suppose, I will give an example now. Suppose x squared plus 2y squared, 2y squared plus xy minus 3x minus suppose 2y equal to 7. You can differentiate this normally, but and then factorize dy by dx and then solve it. Now we will try and see what I mean. What is the derivative of 2x? Because we are differentiating with respect to x, this will be 2x. But derivative of this is something to power of, that's something same as u, y to power of 2. Y is a function of x. Therefore, this will be 4y dy by dx. Here, we are in this part, we are not writing dx by dx because dx is 1. We are differentiating with respect to x. Therefore, there is no dx by dx. Actually, it is 1. No need to write. But here, when in this one, when you are differentiating with respect to x, dy by dx is not 1. Therefore, you have to write the value of dy by dx here, and let's see what is that. Now, here we have got product rule. What is derivative of x? Is 1. Then 1 times y plus. What is derivative of y? It is dy by dx. Therefore, x times dy by dx. You are differentiating with respect to x. Therefore, derivative of y will be dy by dx. But derivative of x will be 1. Minus 3 minus 2 dy by dx. This derivative of 7 also will be 0. Therefore, the other side will be 0. Now you can factorize dy by dx. If you factorize dy by dx, you are getting 4y here. Therefore, this we wrote. Here you are going to get 1x. And here you are going to get negative 2. The others, I will take other side. Therefore, we have negative 2x. This one here. And then this one, negative y here. And then we have got a negative 3, which goes that side will be positive 3. Therefore, dy by dx is equal to negative 2x, negative y, plus 3 divided by 4x plus, 4y. 4y plus x minus 2. Then I divided, to get dy by dx, this will be divided by this. Therefore, this is an equation for this function. Now, I will give another question which has been in your examination. Now, it is given to us x plus y. Therefore, there is another example. X plus y to power of 3 is equal to 3x squared minus 3y minus 2. First of all, it is asking us to differentiate these and find dy by dx in terms of x and y. That means exactly same as we have done here. Exactly same as this. Now, okay, we have something to power of 3. Therefore, this first step is 3x plus y to power of 2 times 1 plus dy by dx. And this side, I'm differentiating. No need to bring to one side, or you can bring to one side. Doesn't matter this. Okay, now you can say that this is 6x, derivative of 3x squared will be 6x, minus 3 dy by dx, and negative 2 will be 0. So we have this. I will expand this and rearrange everything. So dy by dx is one side, the other things will be other side. Therefore, this is 3 times x plus y square plus 3 times x plus y squared dy by dx, and equal to 6x minus 3 dy by dx. Okay, I can bring all the terms with dy by dx to the left hand side and other terms to the right hand side. Therefore, I am having 3x plus y square dy by dx plus 3 times dy by dx is equal to 6x minus 3 times x plus y squared. You can see that all the terms are multiple of 3, therefore we can divide everything by 3, and then this will cancel off, this will be 2, this will go also. Therefore we are having something like that. Now if I factorize, dy by dx. On the left hand side, I am going to get x plus y square plus 1 dy by dx is equal to x minus, 2x. 2x minus x plus y squared. Then I can say dy by dx is equal to 2x minus x plus y squared divided by x plus y squared plus 1. Therefore, this is our derivative. Okay, it says that show that the point, now it's asking us show that the point P 1, 0, 0, 1. Let's check the question paper 1, 0. The question paper 1, 0. The point 1, 0 lies on the curve. Okay, and then he is asking after that to find the equation of normal, and all the things can be done. But let us show what I mean by this. That means x is equal to 1, y is equal to 0. It is on the curve. You need to put it on the first equation, on the relation given here. Therefore, this goes on this equation. Okay, now let us put it there. We are getting x is 1, y is 3. Let me bring that equation down here, so then it will be next to us, so we can okay, now x is equal to 1, y is equal to 0, therefore 1 okay, this is 1 plus 0 to power of 3 is equal to 3 times 1 square minus 3 times 0 minus 2. Over here you are getting 1 is equal to 3 minus, this will be 0 minus 2, which is 1 is equal to 1, so that this point, so P lies on the curve. Okay, now he's asking to find the equation of the normal to the curve. Okay, if I want to find the equation of the normal to the curve, first I have to find dy by dx at the point P, because we have x and y. I can substitute x and y in that and get the value of dy by dx. Therefore, dy by dx at x equal to 1, y equal to 0 is 2 minus 1 plus 0 squared divided by 1 plus 0 squared plus 1. So this will be actually 1, this will be 1 divided by 2. Therefore, this is the gradient of the tangent line. Now, if I want to find the gradient of normal line, I should multiply by negative and reverse it. So we know that m dash is equal to negative 1 over m. So m dash, that means gradient of the normal line is equal to negative 2. Now I can easily write the equation. Therefore, y equal to mx plus c, y will be m is negative 2, negative 2x plus c. We know that x is 1, y is 0, x is 1, y is 0, that means c is 2. Therefore, y is equal to negative 2x plus 2. This is the equation of the normal to the curve. Now he's asking find the point of intersection and say there is only one point of intersection. Then we have to substitute for y and then try to solve it and show that there is only one solution for that. I'm not going to continue this. I am doing all these papers, and you can watch that paper separately. Now we wanted to discuss about differentiation, which we have done. Okay, so this is the derivative of the implicit function. So you can treat them as a usual function, and you can find dy by dx by same method. You only remember you are differentiating with respect to x. Therefore, derivative of y will be dy by dx, and derivative of x is 1. Thank you for watching. We'll see you in the new videos.